Identifying prime factors. Now remember, before that we know that if a number has only one factor pair, then that number is a prime number. So therefore, a prime number can only be divided by 1 and itself. For example, 7. The factor pair for 7 will be 1 times 7, right? 7 equal 1 times 7. So therefore, 7 can only be divided by 1 and itself. On the other hand, a composite number is a number that can be divided by one other number besides 1 and itself. For example, the number 9, which is divisible by 1 and 9 and also by 3. So therefore, 9 is a composite number. So a number's prime factors are the set of prime numbers. Okay, this is very important. A set of prime numbers only, which can be repeated, that equal the number when multiplied together. So let's have a look at one example, 10, the number 10. Now, number 10, the prime factors for number 10 is 2 times 5. 2 being a prime number, 5 being a prime number. So when 2 multiplied by 5, we get 10. So this is one example here. Another example, let's look at 30. 30 can be obtained by 2 multiplied by 3 multiplied by 5. All these three are prime numbers. So they are also the prime factors for 30. Now notice that in these two examples, each of the number appears only once. The prime number can appear repeatedly, as can be seen in this example here. Let's have a look at number 72. Number 72 can be obtained by 2 times 2 times 2, and then times 3 times 3. So 2 is repeated 3 times and 3 repeated twice. So then how can we find the prime factors of a number? Now, an easy way is to use a factorization tree, right? So there are 4 steps in coming up with a factorization tree. Number 1, split the number into any 2 factors and check off, okay, check off the original number. If either of these factors is prime, we circle it, okay, we circle the prime. Repeat steps 1 and 2 for any number that is neither circle nor check. So when every number in the tree is either check or circle, the tree is then finished, and the circled number are the prime factors of the original number, right? It's very easy. Let's have a look at one example. So we want to find the prime factors for the number 56. So we start with 56, and we can split 56 into 2 prime here, right? 7 and 8. Now 7 here can be divided by 1 and itself only, so 7 is a prime number. So therefore we circle 7, and not to forget, tick number 56. Now number 8 can be further divided into 2 factors. In this case, 2 times 4, where 2 is a prime number. So therefore we tick number 8. Now number 4 can be further split into 2 numbers, which is 2 times 2. So we tick number 4 and we circle 2 and 2. So with all the ticks and circles, we have finished the factorization tree for 56. And the prime factor will be 2 times 2 times 2 times 7. So therefore, this is how we find the prime factors for the number 56. What happens if the number is a prime number itself, for example 7? Right? In this case, the factorization tree is simple. is just the number itself, okay? So every prime number is its own prime factor. Now, there are some tips in building the factorization tree. So whenever possible, we try to factor out the number 5 and 2 first. Why? Because it's quite easy to tell whether a number is divisible by 2 and 5. For example, let's take a look at the number 84. Now 84, straight away we know that it can be divided by 2. Okay, if you divide by 2, you get 42. And we know that 2 is a prime number, so we tick 84. Next, we look at the number 42. The number 42 here, we can split into divide by 2 again, right? If you divide by 2, what do you get? You get 21. So therefore 2 is a prime number, and we tick 42. Now 21 here can be split into 3 times 7, and we know that number 3 and number 7 are prime numbers, and we tick 21. So therefore the prime factors for 84 will be 2 times 2 times 3 times 7 here, right? So this is how we build our factorization tree. Of course, there's another way of factorizing the trees. For example, 42 here, we can factors into 7 and 6 instead of 2 and 21, right? And then recognizing 7 being a prime number, we circle, and the 6 here we can further split into 2 and 3. The end results are similar, okay? They are the same. How about for prime number? If you are given a number that is a prime number, how do you find the factorization tree? Now, first of all, let's have a look at 71 here. See, 71, we can easily tell that it's not divisible by 2 or by 5, okay? So, a side knowledge for you here, if a number less than 100 isn't divisible by 2, 3, 5, or 7, then it is a prime number, okay? So, how can we test whether a number can be divided by 3? We can do that by finding the digital roots of a number, in this case 71, right? How to find the digital root is by adding up the digits together. For example, 71, we get 7 plus 1 equal to 8. So 8 cannot be divided by 3, right? A number is divisible by 3 if the digital roots contains 3, 6, and 9. So 8 is not dividable by 3. How about 7? So we know that it's not 71 is not divisible by 2, it's not divisible by 5, and we have tested that it's not divisible by 3. So how about 7? Is 71 divisible by 7? No. 71 divided by 7, we get 10 with a remainder of 1. So therefore, 7 is also not a factor of 71, right? Now, in this case here, we have this condition fulfilled, right? It's not divisible by 2, 3, 5, or 7. So therefore, 71 is a prime number. And that's all. For a prime number, it is the prime factor.